Write down area bounded by the curve. Area bounded by the curve y is equal to f of x x-axis and between the ordinates at x is equal to a and x is equal to b. Area bounded by the curve y is equal to f of x x-axis and between the ordinates at x is equal to a and x is equal to b is given by integral a to b f of x mod dx. Since area is always positive, for which we are taking the absolute value of f of x, so here three cases arises. This is the curve y is equal to f of x. X is equal to a is an ordinate or vertical line. X is equal to b is the another ordinate. Okay. This area is given by integral a to b. This area is integral a to b f of x dx. Right? If the curve y is equal to f of x is above x-axis, the area will be positive. If the curve is below x-axis, the area will be negative. Okay, that's why we have taken absolute value of f of x. So here three cases arises. Case one, if f of x is greater than 0, that means f of x always takes positive value, then area equals to integral a to b f of x dx. That means the curve is above x-axis. Clear? Case 2, if f of x is less than 0, then area equals minus integral a to b f of x dx. Area equals to minus integral a to b f of x dx. Ordinate at x is equal to a, ordinate at x is equal to b. This is second case. If the curve is positive for some values of x and negative for some values of x, that is case 3. Suppose the structure of the curve is like this. X is equal to a. This is x is equal to b. Okay. This area is negative area. So the point of intersection of the curve and x-axis we see. and this area is positive area. So required area is equal to minus integral A to C f of x dx. That in the interval A to C curve lies below x-axis, and plus integral C to B f of x dx. Right? I hope it is clear to you. Chinmay, Vishnu, is it clear? Rajlakshmi, write in the chat box, is it clear? Next. Okay. Then come to second point. Area bounded by the curve. Area bounded by the curve x is equal to f of y-axis and between the abscissae at y is equal to A and y is equal to B is given by integral A to B f of y mod dx. Integral A to B f of y mod dx. Suppose this is the structure of the curve. X is equal to f of y. There is an abscissa at y is equal to A and another abscissa at y is equal to B. So this area, that is area bounded by the curve x is equal to f of y, y-axis, and between the abscissae at y is equal to A and y is equal to B, this area is equal to integral A to B f of y mod or x mod dy. Right? Here also three cases arises. If the curve y is equal to x is equal to f of y lies to the right of the y-axis, then curve is positive. If it lies to the left of the y-axis, it is negative. So case one. The curve lies right to y-axis. X is equal to f of y. So required area is equal to, so y is equal to A, y is equal to B. So required area is equal to integral A to B f of y dy. Right? Case 2, if the curve lies to the left of y-axis, the first structure of the curve is like this. So x is equal to A. This is a many one curve, sorry. This area is equal to integral A to B f minus integral A to B f of y dy. Then come to case 3. y is equal to b. Suppose meets y-axis at C. This area is positive and this area is negative. So required area is equal to integral A to C f of y dy minus integral C to B f of y dy. Required area is equal to integral A to C f of y dy minus integral. This is negative area and this area is positive area, right? I hope it is clear to you. Chinmay, Vishnu, Pankaj, Rajlakshmi, is it clear? Write in the chat box. Yes, first case is for positive. First case for positive. Okay, let us come to discuss a couple of questions on this concept. Question number 1. Find the area bounded by the curve Find the area bounded by the curve y is equal to e power x-axis, and between the ordinates find the area bounded by the curve y equal to e power x-axis, and between the ordinates at x is equal to 2 and x is equal to 3. Okay. So to find the area, you have to remember the graph of the standard curves. You know, u power x is a strictly increasing function. Structure of u power x like this. So there is an ordinate at x is equal to 2, another ordinate at x is equal to 3. So we have to find this area. The curve is above x-axis. Okay. So required area is equal to, this is y is equal to e power x. So write down required area. Required area is equal to integral 2 to 3 e power x dx. You know, indefinite integral of e power x is e power x. This is equal to e power x. Will be evaluated between the limits 2 to 3. This is equal to EQ minus E square. This is the answer, right? Then come to second question. Find the area bounded by y equals to sin x x-axis and between the ordinates at x is equal to pi over 6 and x is equal to pi over 3. Find the area bounded by y is equal to sin x-axis, and between the ordinates at x is equal to pi over 6 and pi over 3. To come to the solution, y is equal to sin x is equal to pi over 6, x is equal to pi over 3. Okay. So we have to find the area of this strip. So required area is equal to integral pi over 6 to pi over 3 sin x dx. The indefinite integral of sin x is minus cos x, and it will be evaluated between the limits pi over 6 to pi over 3. This is equal to minus of cos pi over 3 minus cos pi over 6. Okay. This is equal to minus of cos pi over 3 is 1 by 2 minus root 3 by 2. So this is equal to root 3 minus 1 by 2. This is the final answer, right? These two questions are very rudimentary questions, right? So gradually we'll increase the standard or difficulty level of the questions. Chinmay, Vishnu, is it clear? Write in the chat box, Chinmay. Okay. Then come to next question. Find the area bounded by the curve. Find the area bounded by the curve y is equal to x into mod x-axis, and between the ordinates at x is equal to minus 1 and x is equal to 1. Find the area bounded by the curve y is equal to x mod x-axis, and between the ordinates at x is equal to minus 1 and x is equal to 1. Okay, first of all, we have to draw a rough sketch of the curve. So the function is y is equal to f of x is equal to x into mod x. To sketch the curve, we have to redefine the curve. You know, mod x is equal to x if x is greater or equal to 0. Mod x is equal to minus x if x is less than 0. So if you redefine this function, that will be x into x, that will be x square if x greater or equal to 0, minus x square if x less than 0. Okay. So y is equal to x square is a upward directed parabola, and y is equal to minus x square is a downward directed parabola. So for positive value of x, the structure of the curve is like this, and for negative value of x, the structure of the curve is like this. This curve, since all even parts of x are there, the curve is symmetric about x-axis. So this is x is equal to 1. This is x is equal to minus 1. All right. So this area is equal to this area, right? So, but numerically this area is equal to this area, but this area is negative and this area is positive. So required area is equal to twice of, this is 0, integral 0 to 1 x square dx. We should calculate it like this, my integral minus of integral minus 1 to 0 x square dx plus integral 0 to 1 x square dx. So this area same. That's why we are taking twice of integral 0 to 1 x square dx. So twice of x cube upon 3 evaluated between the limits 0 to 1, 2 into 1 upon 3 minus 0. This is equal to 2 upon 3. Right? Is it clear? Then come to next question. Find the area bounded by ग्राफ रिपीट करिए. Yes, y is equal to f of x is equal to x into mod x. To sketch the curve, we have to redefine. So if x is positive, mod x will be x, that is x square. If x greater or equal to 0, if x is negative, mod x will be minus x square. If x less than 0, right? Clear? This is x is equal to 1. This is x is equal to minus 1. Okay. Next question, find the area bounded by the curve. Bounded by the curve y square is equal to x cube, x axis, and its double ordinate. And its double ordinate at x is equal to 2. Find the area bounded by the curve y square is equal to x cube, x axis, and its double ordinate at x is equal to 2. Take 2 minutes of time, try to solve this. Y square is equal to x cube. So y is equal to plus or minus x raised to the power 3 by 2. The structure of the curve is like this. This is called Newtonian parabola. There is an ordinate at x is equal to 2. This is the ordinate at x is equal to 2. Okay. And the curve is symmetric about x-axis. So this area and the numerical these two areas are equal. So we can calculate area of the upper region. Okay. Twice of required area is equal to required area is equal to integral twice of integral 0 to 2 x raised to the power 3 by 2 dx. This is equal to 2 into x raised to the power 5 by 2 upon 5 by 2. Limit is 0 to 2. So 4 by 5 into 2 to the power 5 by 2 minus 0. 2 to the power 5 is 32. Root over 4 root 2. So 16 root 2 upon 5. Chinmay, 16 root 2 by 5. Chinmay, you are not correct. Quickly note it down. Next question. Find the area of the ellipse. X square upon a square plus y square upon b square is equal to 1. Find the area of the ellipse. X square upon a square plus y square upon b square is equal to 1. Try to find the area of the ellipse. X square upon a square plus y square upon b square is equal to 1. Yes, double ordinate. If for one value of x, there exist two values of y, then if for one value of x is equal to k, suppose there exist two values of y, then x is equal to k is called a double ordinate of the curve. Right? Let us consider the parabola y square is equal to 4x. If we take x is equal to 1, then y, the value of y will be plus or minus 2. If you take x is equal to 2, then the value of y will be plus or minus 4. So for parabola y square is equal to 4x, x is equal to 1 is a double ordinate, x is equal to 2 is a double ordinate, x is equal to 3 is a double ordinate. Chinmay, is it clear? Chinmay? Okay. Find the area of the ellipse x square upon a square plus y square upon b square is equal to 0, is equal to 1. The ellipse x square upon a square plus y square upon b square is symmetric about x-axis as well as y-axis. Okay. And all of you know what is the structure of the ellipse x square upon a square plus y square upon b square is equal to 1. This is the structure. Okay. So this area is equal to this area is equal to this area is equal to this area. If we can find area of this region, then we can find the area of the total region by multiplying it with 4. Sir, good morning. This is A0. This is minus A comma 0, 0 comma B, 0 comma minus B. So required area is equal to 4 integral 0 to A f of x dx. required area is equal to 4 integral 0 to f of x dx. So we have to write down the equation in the functional form. So y square by b square is equal to 1 minus x square upon a square. This is equal to a square minus x square upon a square. Y square is equal to b square upon a square into a square minus x square. So y is equal to plus or minus b upon a into under root a square minus x square. Since we are taking the curve in the first quadrant, we have to take the positive sign only. Okay. This is equal to 4 into b upon a integral 0 to a under root a square minus x square dx. 4b to a integral 0 to a under root a square minus x square dx. From indefinite integral, integral under root a square minus x square dx is equal to x by 2 into under root a square minus x square plus a square by 2 sin inverse x by a plus of c. The indefinite integral of under root a square minus x square dx is equal to x by 2 under root a square minus x square plus a square by 2 sin inverse x by a, right? So, so guys, quickly note, I'll use the next page. Some space here, okay. So required area is equal to 4b by a into x by 2 under root a square minus x square plus a square by 2 sin inverse x over a limit 0 to a. Okay. This is equal to 4b by a into, if you substitute x is equal to a, this one will be 0. A square minus a square will be 0. If you substitute x is equal to in the second function, sin inverse a by a is 1. Sin inverse 1 is pi by 2. A square into pi by a square by 2 into pi by 2 will be a square by 4 minus. If we substitute x is equal to 0, the first function will be 0 and the second function also will be 0. This is 0. So value is equal to pi AB. So required area is equal to pi AB. Okay. Got it? So area of the ellipse x square upon a square plus y square upon b square is equal to pi AB. बुझिपाल पिले चिन्मय विष्णु मौली पंकज राजलक्ष्मी then come to next question. Find the area bounded by y is equal to ln x, y axis, and between the axis I at y is equal to a and y is equal to b. Find the area bounded by y is equal to ln x. y-axis and at y is equal to 2 and y is equal to 3. And the area bounded by y is equal to ln x, y-axis, and between the axis I at y is equal to 2 and y is equal to 3. Y is equal to ln x, the structure of the curve. This is the graph of y is equal to ln x. Strictly increasing curve. There is an abscissa at y is equal to 2 and another abscissa at y is equal to 3. We have to find area of this region. Since we are evaluating the area with respect to y-axis and abscissae, so x should be a function of y. So here it is given y is a function of x. So y is equal to ln x implies x is equal to e raised to the power y. So required area is equal to equals to integral 2 to 3 e raised to the power y dy. This is equal to e raised to the power y between the limits 2 to 3. This is equal to e cube minus e square. Right? The first part is over. Second part, area included between two curves. Area included between two curves. Area included between two curves. Okay, or area bounded by two curves. First part, area bounded by the curve y is equal to f of x, y is equal to g of x. Area bounded by the curve y is equal to f of x, y is equal to g of x, x-axis, and between the ordinates at x is equal to a and x is equal to b. Between the ordinates at x is equal to a and x is equal to b, where f of x greater than g of x for all x belongs to interval a b is integral a to b f of x minus g of x dx. That is integral a to b upper curve minus lower curve dx. Area bounded by the curve y is equal to f of x, y is equal to g of x. So try to understand. Suppose this is the curve y is equal to f of x, and this is the curve y is equal to g of x. There is an ordinate at x is equal to a and another ordinate at x is equal to b. Okay. So the required area is area of this strip or this region. So area of this region is equal to total this area. So this area is equal to integral a to b f of x dx minus area bounded by the lower curve. Lower curve is this area. Minus integral a to b g of x dx. So the required area is equal to integral a to b f of x minus g of x dx. Is it clear? Vishnu, Chinmay, Rajlakshmi. Okay. So then come to second case. If the two curves are intersecting curves. If the two curves are intersecting curves, if the two curves are intersecting curves. If the two curves are intersecting curves, then how to find the area? So area bounded by the curves, area bounded by the curves y is equal to f of x and y is equal to g of x is integral alpha to beta f of x minus g of x dx, where alpha and beta are x coordinates where alpha and beta are x coordinates of points of intersection of f of x and g of x, where alpha and beta are x coordinates of a point of intersection f of x and g of x, and f of x is this is x is y is equal to f of x, this is y is equal to g of x. So area of this region, so x coordinate of point of intersection, this is x is equal to alpha, this is x is equal to beta. Again we will apply the formula upper curve minus lower curve. So required area is equal to integral alpha to beta, upper curve is f of x minus g of x dx. This is our case 2. Quickly note it. Then come to case 3. So this is y is equal to f of x. This is y is equal to g of x. X is equal to a. This is x is equal to b. And let x coordinate of a point of intersection of these two curves be c. This is x is equal to c. Then area bounded by f of x, g of x, and x-axis. So this area plus this area. So required area is equal to integral a to c f of x dx plus integral c to b g of x dx. This is our case 3. Then come to case 4. So this is the curve y is equal to f of x, and this is the curve y is equal to g of x. And ordinate at x is equal to a, and another ordinate at x is equal to b. Let the coordinates of x coordinate of point of intersection of these two curves be x is equal to c. So in the interval a to c, upper curve is g of x, lower curve is f of x. In the interval c to b, upper curve is f of x, lower curve is g of x. So required area is equal to integral a to c, upper curve is g of x, minus f of x dx plus integral c to b f of x minus g of x dx. Right? I hope it is clear to you. Did you understand, guys? Let us come to solve couple of questions on these concepts. Okay. First, take a very simple question. Find the area bounded by the curve y is equal to sin x g of x minus f of x. Case 4. Case 4 is like this, na? This is f of x, upper curve. This is g of x. This is x is equal to c. X is equal to a is an ordinate. X is equal to b, another ordinate. This area is integral a to b g of x minus f of x dx plus this area is integral c to b f of x minus g of x dx. Right? Remember, is it clear? Okay. Find the area bounded by the curve. Find the area bounded by the curve y equals sin x, y equals cos x, y-axis, and which lies in first quadrant. And which lies in first quadrant, right? Area bounded by the curve y is equal to sin x. Y is equal to cos x. Okay, which lies in first quadrant. That means this area. This is the curve y is equal to sin x. This is the curve y is equal to cos x. So we have to find the point of intersection of these two curves. For point of intersection, we have to solve the equation simultaneously. Sin x is equal to cos x. This implies tan x is equal to 1. This implies x is equal to pi over 4. This is x is equal to pi over 4. Right? So upper curve is cos x. So there is an ordinate at x is equal to 0. Another ordinate is x is equal to pi over 4. So required area is equal to integral 0 to pi over 4 upper curve minus lower curve cos x minus sin x dx. This is equal to sin x plus cos x, and limit is 0 to pi over 4. This is equal to sin pi over 4 plus cos pi over 4 minus of sin 0 plus cos 0. Sin pi over 4 is 1 by root 2. Cos pi over 4 is 1 by root 2 minus 0. This is equal to 2 over root 2 is equal to root 2. Okay. Next question. Find the area bounded by the curve y is equal to x square parabola. Find the area bounded by the parabola y is equal to x square and x plus y and the line. Y is equal to three minus 2x. And the area bounded by the parabola y is equal to sorry. Okay. Find the area bounded by the parabola y is equal to x square and the line y is equal to 2x minus 3. Okay, try to solve this question. Come to the solution. Y is equal to x square is a upward directed parabola. That's that. Okay. And y is equal to 3x minus 2. So x-intercept of the line is 2 by 3. Y-intercept of the line is minus 2. So the line is like this. Okay. Y is equal to 3x minus 2 and this is y is equal to x square. We have to find the area of this region. These are two intersecting curves. To find the area, we have to find the x coordinates of the point of intersection if you want to find the area with respect to x-axis or with respect to coordinates. So one of the curve is y is equal to x square. Another curve is y is equal to 3x minus 2. So x square is equal to 3x minus 2. This implies x square minus 3x plus 2 equals to 0. X square minus 3x plus 2 is equal to 0. So factorizing, this one will give you x minus 1 into x minus 2 is equal to 0. This implies either x is equal to 1 or x is equal to 2. So this is x is equal to 1 and this is x is equal to 2. Right? So required area is equal to, upper curve is the line, required area is equal to integral 1 to 2, upper curve is 3x minus 2, minus lower curve is x square into dx. This is equal to 3x square by 2 minus 2x minus x cube upon 3. Limit is 1 to 2. This is equal to 3 into 2 square is 4 by 2 minus 4 minus 8 by 3 minus, if we substitute the lower limit, 3 by 2 minus 2 minus 1 over 3. Okay. Now you can calculate it. I hope it is clear to you. तुम्हारा फर्स्ट सेशन तो ओवर हो, सेकंड सेशन स्टार्ट हो 9:15, एक्जाक्टली 9:15 रे जॉइन करबो सेकंड सेक्शन रे हमें 2024 और 2025 रो सब पीवाईक्यू जेईई मेंस रो पीवाईक्यू सब डिस्कशन करना बा। राजलक्ष्मी, इट इज क्लियर? पंकज एंड राजलक्ष्मी, स्मिता रानी, ओके, राजलक्ष्मी, पंकज, विष्णु, चिन्मय, तुम एक्जाक्टली 9:15 रे जॉइन करिवो। एबे जदि तुमे ब्रेकफास्ट करना परनियो 9:15 रे 2024 और 2025 रो पीवाईक्यू सब डिस्कशन करबी हला। वर्तमान फर्स्ट सेशन ओवर, सेकंड सेशन स्टार्ट करबा एक्जाक्टली एट 9:15।